Last but not least, we're going to talk about rate of change. So if you think about, we've been talking about the rate of change at an instant, that's the derivative. We know that the instantaneous rate of change of any given function is the derivative at that point. We also know how to find the average rate of change. This is something that we've been doing for a really long time, but sometimes we haven't actually called it average rate of change. I think it's in Algebra 2 that we introduce it as average rate of change, but really it's just the slope. So if you think about how fast is something changing, it's like how fast is the y changing with respect to how fast the x is changing. Now when we were looking at lines, this has a constant rate of change, right? So if I look at this line, the y is changing at the same speed with respect to the x from this point to this point, or from this point to this point. It's a constant rate of change. But for other functions, that's not the case. So if I have this parabola here, I'm just going to draw right over that. If I have the parabola, the average rate of change from here to here might be different than the average rate of change from here to here. Do you see how that's actually a significantly steeper slope? So basically, the way we find the average rate of change is we draw a secant line. Remember, a secant line is just a line that goes through the function at 2 points. So we draw a secant line from the first point to the second point, and then we just find the slope in between those 2 points by using our slope formula, change in y over change in x. So let's look what that looks like. So I need the average rate of change from x equals 10 to x equals 30 on this function. So the first thing is I need to figure out what those 2 points are, right? I need to find the slope in between those 2 points. So I'm going to write down those points. Well, let's see. When x equals 10, what does y equal? So that would be 10 cubed. Oh man, that was ugly. 10 cubed plus 2 times 10. So that equals 1020. So when x equals 10, y equals 1020. Now what happens when x equals 30? So I need this second point to find the slope in between the 2 points, right? So when x equals 30, I have 30 cubed plus 2 times 30, because I just plug in 30 for x, and I get 27,060. Okay, so here are my 2 points, and I need to find the average rate of change between the 2 of them, which means I just find the slope of these 2 lines, which is the change in y, which is f of 30 minus f of 10, right, because those are the y values, divided by the change in x, which is 30 minus 10. So I have 27,060 minus 1020 over 30 minus 10, which is going to come all the way out to, if you do some math, 1302. So that is the average rate of change in between x equals 10 and x equals 30 is 1,302. That means for every time it goes up 1,302 and over 1. Up 1,302 and over 1. That's the slope of the secant line. Okay? So this says if this is the function, find the instantaneous rate of change when x equals 10. So I'm going to have you write right here on this. Next to average rate of change, I want you to write slope of secant line. Remember, secant line is one in between 2 points on the graph. And then next to instantaneous rate of change, I want you to write slope of tangent line. Okay? I can't write and talk sometimes at the same time. I wrote the wrong word. All right, slope of the tangent line. So average rate of change, slope of secant line, instantaneous rate of change, slope of the tangent line. So now it's asking me for the instantaneous rate of change when x equals 10. So this was our average rate of change over an interval, just like our average speed over a trip. This is telling me how fast am I going at this exact moment when x equals 10. So that's the derivative. So I do f prime of x. Make sure you write good notation when you're solving for a derivative. Make sure that you write that you're solving for a derivative. Write f prime of x or dy dx, because otherwise you just have some random equal sign and we don't really know what you're solving, right? So f prime of x equals 3x squared plus 2. And we find the instantaneous rate of change would be f prime of 10. So that equals 3 times 10 squared plus 2, which equals 300 plus 2. So the instantaneous rate of change equals 302. And there you go. That's average rate of change and instantaneous rate of change.